Hey guys, Steve Dean here. We're going to use the counter movement jump and the squat jump as an assessment for dynamic lower body strength. We're going to use those tests to gain the eccentric utilisation ratio and also gauge neuromuscular fatigue of the athlete. And we're going to use this with the 400S performance force plate. So the test selection, we've chosen these. We're going to use a squat jump to assess the concentric strength of the leg extensors. The counter movement jump is used to measure the power of the lower limbs. The comparison to the above test allows assessment of the stretch shortening cycle and the calculation of the eccentric utilisation ratio to allow for changes to maximise benefits in the athlete's resistant programs. Improvements in muscular power as assessed by the CMJ are related to improvements in tackling ability, and jumping ability has correlations with sprinting ability. So the test setup, there's one USB cable which you connect the force plate to the computer. Then you use a spirit level to obtain the level of the force plate in directions perpendicular to each other. As I said, with the setup of the test, there's just one USB cable in which we plug into the computer, and we also use this spirit level to obtain the level of the force plate. And as you can see here, that's level, it's ready to calibrate the force plate. Alright, to calibrate the 400S performance force plate, we open up the BMS software, we click on Tools, Configure, head across to the Calibration tab and hit Calibrate Force. We're going to use a 10 kilo weight plate, so we type 10 in there. We put the weight plate on the force plate and hit Read Lower Force. We're also using an athlete that is 73.7 kilograms, so we make that 83.7 here for the enter higher force. We get the athlete to stand on the force plate and we hit Read Higher Force. That gives us a calibration factor of 0.062 and we click Done. 0.062 here, so we close the calibration. To assess the accuracy of the calibration, we've set 0 for force. We ask the athlete to jump on the force plate and do a little jump and hold 1, 2. We stop there. We get the set point 1 through here and the set point 2 we set here. Set mass 73.644. The force plate is accurate. Alright, so obviously with these tests and the test setup, we want something that allows reliable, consistent and a safe test is our number one priority for the athlete. So we always do a hazard identification and risk assessment. Our equipment is calibrated prior to each testing day, and the tests allow real-time results, which is used by us to assess that the proper technique is done on testing, specifically the squat jump, and comparisons can be made with previous week's results. All the testers are trained and experienced, and the exact protocol is always followed. We use the same cues, instructions, and the encouragement remains similar. So there's a number of variables which can affect the accuracy and reliability of the test. The quality assurance issues that we focus on are pre-test diet. So each athlete has a balanced diet provided to them by a nutritionist for lunch, which is given to them prior to each test. The player's diet is variable with players as it depends on their body mass goals, so carbs versus proteins. Through fatigue, it's managed with questionnaires, which is filled out by each player on every training day, and it has questions regarding sleep, training efficacy, fatigue, and muscle soreness, which can affect the results. Medications and illness can also affect the test, and that's conveyed to us by a team doctor. With injuries, we have a spreadsheet on every player's current injury and past injuries which may affect the results of the test. We also do a musculoskeletal screening every week, which is game day plus 2 days. And the environmental conditions remain the same as we're using the altitude chamber. So temperature, humidity all remain constant, and we're not affected by the wind and the sun. The time of the test remains constant. which is within a 30-minute time period of game +2. Athlete preparation: all players prior to the test, which is conducted at the start of their resistance program, have a 15-minute individualised warm-up and preparation program. And this program is based on previous injuries, current injuries, strength and mobility deficits, and activation and mobility for the upcoming resistance program. This changes week by week depending on injuries and issues with the player. In an ideal world, players would do a 10-minute standardised warm-up prior to testing, but we sort of sacrifice that for the good of the athlete's performance. Using a 400S performance force plate, the force plate is considered the gold standard of assessing the counter movement jump. So after calibration is demonstrated, we zero the force plate out. The athlete steps onto the force plate. Once standing upright and still, we press zero data, then click collect data, and the athlete can start the test. For us to standardise, there's no arm swing allowed. Hands are to remain on hips. We allow the athlete to go to whatever depth they feel will elicit the highest jump. This will allow for more consistent results as per the NSSQA guidelines. Legs are to remain in full extension when in the air. Aim to jump as high as possible and stick the landing for 2 seconds. Try and land in the same location as takeoff. Save the data. The athletes will perform 3 counter movement jumps with approximately 2 minutes rest. The same setup applies for the squat jump. However, the athlete starts at a knee angle of 110 degrees using a goniometer. The athlete starts in the squat position, holds that for 3 seconds. This reduces the effect of the stretch shortening cycle and allows comparison with the CMJ to give the eccentric utilisation ratio. Athlete jumps as high as possible, keeping their knees and hips in full extension, holds landing for 2 seconds. We examine the force trace to make sure the squat jump was performed correctly. If it's correct, we save the data. If there is a prior movement, this will show on the force trace. We have negated this by giving the athletes multiple opportunities to familiarise themselves with the test. Once again, 3 tests are done with a 2-minute break. So for the scoring of the test, as I showed before, the variables that we collect, the reason we use these is average force has a typical error of measurement which is less than the smallest worthwhile change in an athlete. That's reported by Cormac et al. In 2008. It also has the greatest chance of detecting performance changes and has a high repeatability with a coefficient variance of 1.57%. We also use peak power output. Peak power on CMJ has correlations with tackling ability in rugby league. We use a maximum rate of force development and flight time. Flight time has a high repeatability with a coefficient variance of 1.88%. Also flight time to contraction time is a ratio. The higher the contraction time compared to the flight time is the increase in neuromuscular fatigue of the athlete. As I've shown on the program, you can choose the variables you want by selecting the boxes and saving them on the Excel spreadsheet. The variables of interest obtained from the software. The difference between the counter movement jump and the squat jump is used to calculate the eccentric utilisation ratio, and this can be calculated using either jump height or peak power. And the study by McGuigan et al. In 2006 shows it correlates well to performance and is sensitive to changes in training of the athlete. It is also used to develop individualised strength and power programs for the athlete to maximise the resistance training benefits. The eccentric utilisation ratio should exceed 1 in well-trained athletes, and as I've said before, the flight time to contact time is a measure of neuromuscular fatigue. Other testing issues, obviously I've spoken about a number of these in the video. Raw data, that's what we are assessing. Within individual changes can be used to assess neuromuscular fatigue, which is usually recovered 48 hours post-game. And this is also compared to perceptual fatigue using the questionnaire and training prescription. The smallest worthwhile change is calculated by 0.2 of the between subject standard deviation and is done using an Excel spreadsheet as shown before. It's calculated for the forwards and the backs. If we put them all into one, it would be too much of a spread across the athletes. Typical error of measurement. In previous research has reported typical error of measurement for the counter movement jump, peak power and peak force is 2.9 and 2.2% respectively, and that was a study by Cormack et al. In 2008. Reliability data for this measurement with the same group of players showed a coefficient variance of 1.8%, and that was done by Twist et al. In 2012. Flight time and relative mean force displayed the highest repeatability with a coefficient variance of 1.88% and 1.57% respectively. With the frequency of use, 48 hours post-game is when we're using it. That's when McClellan 2011 showed that neuromuscular fatigue started to settle. We also compare this with GPS data for each player, as there is a correlation between high running loads and increased neuromuscular fatigue. The counter movement jump has also correlations with lower yo-yo scores, which is also another reason why we're using the counter movement jump. And this can help dictate training 48 hours following a match. If there's still some neuromuscular fatigue about, we can modify that training to reduce the risk of injury. The counter movement jump for the eccentric utilisation ratio is assessed fortnightly. As far as the usefulness of tests in different situations, I'm lucky to be able to use the gold standard measurement for counter movement jump, which is the force plate. In other areas you wouldn't be so lucky to use this because you wouldn't have access to the technology.